Hello friends, welcome to Akulmek Live and my name is Chandrakant. Despite the strong growth of renewables over the last few decades, fossil fuel based remains dominant worldwide. The use of electricity generation continues to increase in both absolute and relative terms. Even today, the fossil fuel generates nearly 65% of the world electricity. The clean energy alternatives are not efficient enough to fill the demand at the moment. The question we need to ask why we continue to make huge dams at very high cost but do not invest in nuclear power plants. Why? Today, about 10% of the world's electricity is generated by 450 nuclear power reactors, and about 50 reactors are under construction. Together, they will cover approximately 15% of the existing capacity. There are, however, major concerns which are preventing wide-scale acceptance of nuclear power plants by various governments across the world from adapting these power generation using the nuclear means. One big fear is accidents like Chernobyl and Fukushima mega accidents. The fallout of these crippled reactors may take centuries to clear up. And the second biggest reason is availability of uranium. USA or United States of America seems to have monopoly on uranium mining, and extracting uranium from seawater is very expensive and time-consuming process. But we have an alternative which is much easier, safer and cheaper to build and operate in the form of thorium-based molten salt reactor or MSR. Today we will analyze how thorium MSR can solve India's future power generation problem at a fraction of a cost. Friends, I will be back with this analysis after a few promotional messages. Don't go anywhere, as an outstanding show coming up right now. Friends, have you ever wondered that making a lasting impression online is similar to landing on the moon? If yes, we have a solution for you. Akulmek Genius program will help you prepare for your upwards trajectory towards success in the digital world. Our program consists of 12 unique tailor-made sessions of 1 hour each, spread over 6 weeks. Akulmek Genius program provide you practical knowledge about how to optimally use online video platform with lights, action, camera, as well as crash course in using virtual screens. The program also includes a session on the grooming and online etiquettes, which are important for running your online sessions and webinars. At the end of the program, our participants would be allowed to make their own videos, which will be published on a very popular business channel called Akulmek Live. This will provide global recognition to all our participants. If you like what you hear, then using the link in the description below, join the program straight away or visit www.akulmek.com and click on Genius program to know more. Welcome back, friends. Let's understand what is the molten salt reactor in the first place. In essence, a molten salt reactor or MSR is a vessel that contains a hot liquid salt in which a nuclear reaction takes place. The salt consists of nuclear fuel like thorium salt and several other compounds that optimizes the reaction. The heat transfer and the stability of the salt is also taken care by this solution. This means the salt mixture is both fuel as well as coolant. This allows for a very high heat production. Unlike the solid fuel, the uranium reactors, the liquid fuel can be kept at an optimum condition at all times without temporarily shutting down the reactor. Now let's discuss why thorium and not uranium. Number 1, thorium is available in India in abundance. Number 2, thorium when combined with other material forms salts, and these are not dangerous to dispose of as a waste, nuclear waste, and I will explain in detail later. Number 3, thorium salt reactors are smaller, less complex, and very safe with no risk of core meltdown. So let's understand how safe is thorium MSR. Three large historic accidents, including Chernobyl and Fukushima, has shown that the major risk during and after nuclear accident lies in the spreading of radioactive iodine into the atmosphere, and cesium as well. These components are product of the nuclear reaction that are formed inside the reactor, and this will be the same process in thorium MSR as well. However, today in light water reactor, there are these are present in the volatile form and can become airborne and can be picked up by living tissue. In case of an accident, iodine and cesium may get into atmosphere and can travel far away from reactor, covering large distances. In molten salt reactor, however, iodine and cesium and other fission products are ionically bound. Ionic binding is an incredible strong chemical bond. It is a reason why you can safely use kitchen salt without having to worry about poisonous chlorine gas coming out of it, even though roughly half of your kitchen salt consists of chlorine. In molten salt reactor, this ionic bonding makes sure that all radioactive components that provide a key radiological hazard are safely bound to the salt and are unable to travel by air. The danger of nuclear meltdown, which is generally viewed as a major concern in nuclear reactor, is simply not present in molten salt reactors because the fuel is not in a solid state. Meltdown occurs when the solid uranium fuel rods overheat in such an extent that material melts, which can have dire consequences. If the material then escapes into as a contaminant, then it can become a serious issue. In MSR, the fuel is expected to be in liquid state, and the structure is engineered to safely accommodate this. Yet, another boundary of safety in MSR is established by the reactive behavior of the salt itself. When the salt is cooled because the pumps are on, the nuclear reaction intensifies. When the salt heats up when the pumps are off, the nuclear reaction slows down or even stops. This load following behavior is convenient operating principle, but also serves as a foolproof safety mechanism. It means that if for whatever reason the cooling pump fails, the reactor heats up to a calculated maximum and simply stops. If for whatever reason the reactor heats up further, another safety mechanism gets activated. This is called freeze plug, also called as melting plug. Both names apply to the same mechanism that consists of section of a salt in drain pipe that is actively kept frozen by an electric fan. If the power fails, the fan stops, the plug melts, and gravity makes the salt drain away to the safety to a specifically designed storage in which the decay heat is released by passive cooling. The big difference with earlier solid fuel designs here is that instead of power being needed to shut down a reactor safely, power is needed to prevent the safe shutdown of a reactor. Therefore, in case control is lost, the only logical outcome is automatic shutdown in case of MSR. Now let's discuss about cost. There is a reason to believe that thorium MSR electricity will be significantly less expensive than electricity from current nuclear technology. Factors contributing to low cost profile are simplified construction, including less expensive safety systems, modular construction approach, simplified fuel and waste handling, higher energy efficiency, and potential for additional processes and earning made possible by thorium MSR high operating temperatures, among others. So you see, we have thorium in abundance. We should actually stop investing in building large nuclear houses which are very dangerous, and we need uranium to run them because uranium is not available in India, but we can use another alternative which is much safer, less expensive, and that will solve all our future problem of generating electricity. While we also keep investing in solar and wind, I think this is a very good alternative. So friends, this is something which I wanted to present to you as the future for India power generation at a lower cost. and I look forward to getting engaged with you. Do write in your comments, and I will meet you next time with something even more interesting.